Hello and welcome, everyone. We're excited to have you all attending today. I'm Jim Olson, Assistant Executive Director of the NTCA, and I hope that all of you and your families are healthy and safe. Today's webinar is titled, It's All Downhill, the Evolution of Slope-to-Drain Shower Pans. Slope-to-drain waterproofing concepts are an essential part of ceramic tile and stone installations. Over time, a variety of installation methods and products have been employed to achieve the required slope to drain. Failure to follow industry best practices can result in costly failures in wet area applications. We will examine some of the historic means, methods, best practices, and forensic examination of failures. In addition, we will focus on new technologies which offer the architect, distributor, and contractor more consistent, reliable, and durable slope-to-drain installations. At the conclusion of this presentation, the participant will be armed with the most current and relevant information regarding slope-to-drain installation details. This presentation is IDCEC and AIA accredited for a 1-hour CEU. Please look to your chat screen for contact information. Our sponsor for this presentation is Noble Company. Please look for their advertisements in Tile Letter Magazine and multiple digital platforms. Now, before we continue, I have some business to take care of. Today's webinar will be muted. Please use the questions area on your computer to type in your questions. We will answer your questions at the end of this presentation. All of our webinars are available to watch at any time on the NTCA YouTube channel. Shortly after the webinars are presented, about 48 hours after it's presented, they'll be available. Please go to the NTCA YouTube channel and subscribe, and you will be notified of all upcoming NTCA videos, including all technical webinars, giving you easier access to watch all current and past programs at your convenience. We will no longer have them archived on the NTCA website. If the audio on your computer is poor, call the number on your invite and listen on your phone. So here we go. Very excited to introduce our speaker today. Our speaker today is Dean Moylan. He's a Division 9 waterproofing, crack isolation, and permeation specialist who advises on some of the most demanding and prestigious projects in the United States. As a 30-year veteran of the tile industry, Dean's relationships with architects, builders, and owners allow him access to some of the most challenging and compelling design issues in the industry. Dean's extensive career on job sites give him a real-world perspective, as he has seen the firsthand success and failures relating to product selection, installation issues, and sequencing challenges. Please welcome Dan. We look forward to it, Dean. Excuse me. I just called you Dan. Sorry about that, buddy.
That's all right.
Welcome,
thanks,
Dean.
Yeah, that's okay. Well, thank you once again, Jim. You know, we're always grateful to be a part of this presentation, and we've done a fair number of these, and they're always very enjoyable. And I want to just throw this out there. Of all the NTCA webinars I've done, this is probably the best looking group I've seen so far. So congratulations. Everyone's happy and healthy at home. And so before you start, a little brief background. My name is Dean Moylan with Noble Company. I have been with them for 21 years. I office out of Las Vegas, Nevada. And for those trivia buffs, they have the most hotel rooms of any city in North America, somewhere north of 170,000 rooms and counting. And we're slowly coming back to life based on recent world events I'm sure you're all aware of. But being here and being involved with so many projects here of a really significant and unique type of footprint has allowed me some great opportunities to explore different types of Division 9 waterproofing applications to installations and challenges. So we're going to see if we can move this thing down the road a little bit. It is AIA approved. And so if you're an architect looking for those credits, you will get that at the completion of today's presentation. Also IDCEC approved for those designers who wish to get those credits as well. But hopefully we have online a good mixture of architects, designers, contractors, maybe some distributors. And we're going to explore, slope to drain has been around for a long time. And for many of us, you might go, gee, I know all about this, and I've heard all about this, and that may be true. But even the pros go back to spring training to sort of reacquaint themselves with the basics. And we're going to look at how over time that concept evolved, and what some of the database information are for architects and spec writers, the standards you want to reference. And also to look at maybe some of the problems and challenges that have been experienced and realized out in the field, and take a look at some new products, some new opportunities to develop slope to drain concepts on your project that work and are consistent and will allow you to have a robust, durable presentation. So we'll take a look at the evolution of slope to drain, some of the sticking points and failure points of slope to drain, the latest developments in slope to drain technology, as well as best practices moving forward. Now, I think we've hopefully all moved past this method of our Saturday night bathing. Back in the day before there were tubs and showers, if you're coming home from the range, you might warm up the kettle on the stove and throw some hot water in your bucket and a brush, and thank goodness we've come a long way from that. But back in the day, I think the Roman Greco era of our civilization, even though this was thousands of years ago, these civilizations really pioneered the early concepts of managing water, storing water, moving it from one place to another, heating water. Both of these civilizations had public baths, and back then, people didn't take a bath every day. In fact, in the Middle Ages, bathing was frowned upon as being a devilish practice. I'm glad I wasn't around then. But nonetheless, in these ancient public baths, they had figured out how to transport water and disperse it in an overhead fashion. And obviously back then, the baths were segregated due, male and female. But bottom line was, thousands of years ago, they had discovered the pleasure, that simple pleasure of having water splash on your head and kind of wake you up and clean you off. But they weren't too concerned about where the water went. As you can see, they're standing almost calf deep in gray water. Wasn't a big concern back in the day. And as we mentioned, these baths were segregated, and oftentimes, before they had figured out plumbing, or if they were in the field, they'd have little like Boca bags. They'd have little small portable leather bags that carried water that they could either wash their hands with or disperse on a branch above them overhead. So people had been wanting to shower for a long time, and it's only been a recent development, in the last several hundred years, since the Industrial Revolution, where bathing on more than a weekly basis, bathing within your own home, became something that the average citizen could do. And so by the 1800s, if you look at that image on the late 1800s, you had kind of the precursor, the predecessor to today's deluge showers. If you go into certain high-end hospitality environments, and I've had the opportunity to stay at a couple of them, I've seen them where they have showers overhead and shower nozzles at your shoulder, at your elbow, at your hip, at your knee. And so if you look at this ancient contraption on the right-hand side of the screen, they kind of had a running start at this concept. And back then it was advertised a very therapeutic way to, heighten the senses of the individual. But you notice there's no shower pan. Those legs are resting on a flat surface. If you look at the slide next to it, you see more of an evolution towards our contemporary shower. Back then you had a tub, and you had the screen ring around the top of the tub, and you had your first early hot and cold running water. But there again, because your shower was taking place inside of a tub, you weren't really that concerned about where the water went. It just flowed down the tub. Now, over time, the 20s, the 30s, the 40s, the 50s, we started to see our first commodity, consumer, affordable tract housing, and you know, the first affordable, mass-produced hot and cold running water. And so, along with these developments, people wanted a shower and a bath in their house. And over time, you know, they took these best practices from a tub application. Obviously, the tub sloped down to the drain, and they realized they had to have that same concept approaching their shower pans. You couldn't be like the ancient Greco-Romans and just have the water pile up in your shower pan, of course, unless maybe your drain's clogged. That's happened a few times before. But nonetheless, as these different standards and installation methods evolved, so did manuals like the Tile Council of North America. For some of you who remember this publication back in the late 70s, early 80s, it was the size of a thin catalog. Now, when I'm on the road, I can almost use these manuals to lift weights in my rooms. They are 300 plus pages, but if you look inside that manual, you will see many different variations on how to approach slope to drain applications in your wet area shower environments. By the 50s, early 60s, and some of us growing up who have been around for a while might recall this in our mom and dads, and maybe even in our own home, this type of typical bathtub shower assembly. You'd have the tub to one side, the enclosed shower, of course, the shower curb with its beautiful quarter round application and its soft pink 4 1/4 white body wall tile. Obviously, this was the predecessor, the precursor of today's typical shower pan. And of course, a variety of methods were used to create the slope to drain. And, you know, I do find it surprising. Up until recently, I spent a lot of my time on the road working with architects, specification writers, developers, and with all the concerted efforts of so many different industry supporters, you know, manufacturers, tile education groups, you would think that it's common knowledge that you have to have a slope to drain. It's still sometimes viewed as an option by certain tile contractors. Some architects aren't aware that it is a requirement, not a recommendation. And so that's why we're here today, to kind of review this concept and see how it's moved forward. Now, again, back in the day, if you look on the left-hand side of the slide, dry pack mortar with a loose laid shower pan, and you know, the tile or stone bonded on top of the dry pack mortar. Of course, the dry pack mortar was reinforced. This was kind of the coin of the realm. This is the way that you created a waterproof shower pan, and it has worked for decades. And in many parts of the country, it's still very popular. Go back to the Northeast, the Midwest, a lot of shower pans are built this way. You look to the right, you have the ANSI A118.10 bonded membrane concept, in which instead of the membrane being underneath the mortar bed, it's placed on top of the mortar bed. And this may be a sheet membrane or could be a liquid membrane. And of course, over time, what's evolved is, back in the day, you maybe flashed up 6, 9, and maybe 12 inches, and the membrane was behind the backer board. Well, what we've seen now with this bonded ANSI A118.10 bonded waterproof membrane, oftentimes you see the membrane carried from the drain on the same plane all the way up to the lid. Why do we do that? Because vapor migration permeation is an issue. We become more aware of that. So people want a waterproof membrane that goes along each shower pan, up the wall to the lid of the shower. Now, I showed this slide for a variety of reasons, and we talk about best practices and sometimes less than that. This is kind of a warning to be careful when you're on YouTube, or if you're an inspired do-it-yourselfer, because you might want to run across things like this and go, oh, okay, this is the way that you do it. Well, a couple of things you might want to note here is there is an approved metal lath that's used to wrap curves and be placed to help retain your mortar on your shower pan mortar bed. And what you're seeing on this slide looks a lot like chicken wire. And oddly enough, in some parts of the country, I lived in San Francisco for about a decade. Unknowingly, unwittingly, I saw rolls and rolls and rolls of chicken wire sold and used. And of course, hard to argue with a contractor who's told you, I've been doing it that way for years, and of course have never had a problem. Now, I'm holding in my hand, this is 2.5 metal lath. I think it's ASTM C847. Don't quote me on that, but this stuff is really sharp. If you're not careful, you cut yourself. But this is actually formed, I'm forming this over the curb. What you're also seeing here that you might not want to get involved with is, it looks like this gentleman's applying the chicken wire right to the bare wood, and then the only option you would have would be to apply your mortar to the chicken wire over the bare wood, which means I think that curve's probably not going to hold water very well. But just be careful, because in real life, I'll show you on some slides coming up the correct way to do that part of the installation. Of course, we're looking at the shower pan, and again, 2.5 metal lath. And what happens sometimes when people staple down lath, if they have the membrane beneath the lath and they staple it down, they're probably going to puncture the membrane. Now, this looks like this was installed over a pre-pitch, okay? Because one of the things we run across when we talk about slope to drain is, and I've had earnest conversations with contractors. Of course, these were on projects were being opened up for forensic examination due to failure, and the comment would be, well, you didn't do the slope to drain. And they'd say, yes, I did. I made sure, they had their loose laid shower pan laying flat on the substrate, but they sloped their mortar bed and their tile down to the drain. And so their thinking was, yeah, I sloped to drain. What they didn't realize was the water that got through the grout joints and eventually percolated through the dry pack mortar would just sit on that flat shower pan. But wherever you have a waterproof membrane, whether it's on your curb, whether it's on your shower pan, you don't want to be anchoring it down with construction staples, some kind of galvanized nails. You're going to puncture the membrane and you're going to have a leak before you even start. Now, assuming all goes well, you're going to have your dry pack mortar that's going to be formed over the top of your shower pan. And of course, a traditional way of doing slope to drain would be using a level and a straight edge to get that 2%, which equals 1/4 inch per foot slope to drain, okay? And again, on the face of it, it would seem like a pretty straightforward, simple application, but the devil is often in the details, and the pros often make it look easy, which means if you're not quite a pro, now look at this shower pan. You can see there's some marks on the back wall. Now, in some cases, a contractor will put little screed strips up, or they'll shoot with a laser level or a level. They'll get a high point they want to work off of, and then they'll use screed strips, or they'll be able to float down from that high point to the drain, knowing that that's that 1/4 inch per foot. And if you look closely at this mortar bed installation, you do see some undulations, some variations. Might not get you where you want to go. Now, looking at the curb, looks like he formed the 2.5 metal lath over the curb. Sometimes you'll see penetrations, nails, anchor points, which if you do, that's already a fail. I don't see any here. And this is straight from the ANSI Standards. And of course, I've got a copy of my ANSI Standards right here. A great reference tool. If you do need an ANSI Standard manual, at the end of this presentation, please contact me, contact our company. We're happy to send you one. But here you see some of the verbiage that's inside the ANSI Standards regarding 1/4 inch per foot and wire reinforcing. It's It's required. It's not recommended. It's not an option. Okay. So you would think pretty straightforward. I've got my level, I've got my straight edge, I've got my laser, whatever you're going to use to form your high and low spot on the shower pan. It would think it'd be common sense. I start on the high end at the back of the shower from the walls and work down towards the drain. But as you can see from these forensic inspectors' examination shots, and by the way, some people say I've lost my marbles, but I actually have them here. See my marbles? Why do I keep them? Because occasionally you're traveling and you see a shower pan that doesn't look like it's sloped to drain. And if you put the ball bearings or the marbles at the back of the shower and just let them roll where they may, you'll find out if you have the correct slope to drain. Now on the slide on the left, you can see these ball bearings wound up down by the curb. Not good. On the image to the right, ball bearings wound up adjacent to the drain. Now what that creates, it creates a bird bath, an area where if someone's showering and there's potions and lotions and conditioners and washed off sunscreen, you name it, next person in that shower where that water's sitting could slip, skid, fall on that wet spot. And so this is why slope to drain is so important, because it creates obviously some issues which may lead to a failure in holding shower water in that shower pan, but it also may create a slip fall hazard that could injure the shower user. Now, a couple other images here. Obviously, cement backer board has been around for a while. Most times used either on the walls of a shower if someone's doing installation of a floor tile or natural stone in a home, maybe used to go over the wood substrate prior to installing tile or stone, but not really supposed to be used in the shower pan of a shower. And as you can see here, you're not really going to you're not going to get any slope to drain here, which is going to cause a problem. If you look on the image to the right, again, using another type of cementitious or fiber backer board, you can see where almost the whole sheet has been used to create the pan. Now, there's going to be no slope here unless the contractor thinks he has to create the slope when he installs a tile on top of it, which is still not going to work because, gosh, you hope a membrane's underneath that backer board, but even still, there's no slope, okay? So these are not best practices. This is not the way you do it. If someone tells you they're using backer board on your shower pan, have them leave the premises immediately. Now, part of correct slope to drain is to have the entire shower had that 1/4 inch per foot, not just the foot or two around the drain having that slope. You can see what happens here. Someone used a large format tile and then they radically sloped the area right before the drain. And of course, with a large format tile, you have to pizza pie cut the tile so it can accommodate the multi-pitch towards the drain. It just ends up looking horrible. Most times on traditional clamping ring drain assemblies with slope to drain, you're going to see a smaller format tile used, 1x1s, 2x2s, sometimes maybe 3x3s. For this reason, obviously, if you're using a linear drain, and by the way, with linear drains, that same 1/4 inch slope to drain is in effect. But with a linear drain and single pitch sloping, it opens up the availability and possibility of using large format tile or stone. On the image to the right, again, this almost looks like, remember we saw that mortar bed a couple slides ago? This almost looks like the finished work on top of that, but you can see the uneven mortar work on the back wall resulted in uneven tile work, and you don't really see much of a slope. You see maybe a little bit on the wall, on the left-hand wall, close to the drain where it slopes down. But again, this is not going to fly in terms of correct slope to drain. or the correct management of water to the drain. Now, some of the, again, the historical methods of, besides craftsmanship, where you used, straight edge and level, some companies have provided these preformed screeds and pre-assembly of a framework, a skeleton, so to speak, that would ramp. These ribs would ramp and slope down to the drain, and then the contractor would pack mortar in around the skeletal outlines to form a correct sloped drain. Also, too, a variety of manufacturers have created a EPS foam template, and I think I have right here somewhere. Here we go. Here we go. Here's an example of the foam. Okay, it's EPS foam, and it's used. It's tapered down. Again, this is a pre-pitch. You don't install tile or stone on top of this. You put the loose laid shower pan on top of this, then the mortar. And one of the things we're note here about EPS foam is it's very soft and compressive, and that will become relevant in a couple of slides. But nonetheless, these are different ways to sort of aid the installer in getting a correct slope to drain. Now, a couple of things have happened since the Great Recession, Depression. Number one, a lot of qualified installers have just left the industry due to the downturn in economy, due to retirement. That combined with logistics, as let's just say even a 50-room shower, 50-room smaller hotel, or a 100-room student dorm, and think 500 rooms. Well, if you're doing dry pack mortar, you have to get sand, the cement, the water, up the man lift into the rooms, and then you have to schedule, okay, my guys are gonna go in there and they're gonna mud the pans, and that's gonna take X amount of time. And then depending where you're at in the country, how long is that mortar bed gonna take to cure? Could be a couple of days. So a lot of time, a lot of money, a lot of logistics. And then of course, you wind up with that shower pan where the ball bearings are rolling the wrong way. So to respond to that, all those concerns, several manufacturers have come out with prefabricated foam trays and pans, and they're literally designed to be the slope to drain from which tile or stone is directly installed on top of that foam template to ensure that you have a consistent slope to drain in every shower, every project. Now, I've actually written an article on this called Make Sure Things Pan Out. And as I often state in my presentations, this article is available. It's totally objective, does not tout anyone's system. This gives you an overview of the evolution of this concept. If you have trouble sleeping at night, get a copy. It'll have you to bed in a matter of minutes. But in this article, we note that this concept is taking hold. And I believe over the next 5-10 years, you'll see more and more of these prefabricated pans and trays being used. But words of the wise, they are not all created equal. I know that happens oftentimes when people think of linear drains. They don't realize linear drains have a lot of variety in the way they're built. They think of ceramic mosaic tile or tile in general. They don't realize there's all kinds of ceramic tile. Well, there are a variety of prefabricated pans and trays. They're not all created equal. Some of the biggest concerns out there are that because they're foam, and you saw how easily I squeezed that 3-pound foam a couple of slides ago. Well, that same concern holds true with these prefabricated pans and trays. And here you're looking at some examples. These are not all of the prefab pans and trays out there, but these are several, 4 of them that you may have seen in the marketplace. The top left-hand corner, this is a pan and tray that's been molded. Okay, it's created in a mold. It is not waterproofed. It has a predetermined location for the drain, so it has to fit a certain size shower pan. The drain to the top right is also EPS foam. With this product, they've actually pre-waterproofed it and supplied a drain. So, and there are pros and cons to that as well. Decide whether that's what you want for your application and your job. Again, designed to fit a certain size assembly. The bottom left hand, several manufacturers have done some things to address the point loading and compression concerns, because what happens if you have a 3-pound extruded or expanded polystyrene and the contractor happens to kneel on the foam, which contractors often kneel, or someone drops a tool, or between the installation of tile and after the installation of the foam tray, someone gets it there on a ladder and some tray damages that foam tray and pan. Well, in one case, a manufacturer has added a honeycomb matrix to the top of that 3-pound foam, 10 times stronger than the foam itself. And in this case, available in custom sizes, can be cut in the field to adjust for any kind of variables in the field. The prefab tray to the bottom right is an extruded polystyrene, which is a more dense, watertight, water-resistant foam. Also has a cementitious and fiberglass coating on the face of it to, again, provide a waterproof barrier and to add some additional dimensional stability and strength against impact. So we're going to go to our next little video here. Let's see if I can start this thing. I may have to move my my little image here. Here we go. Okay. Okay, you're going to see a ball drop. You're going to see a pan dent. What's important about that? Well, there's an IAPMO test protocol, IAPMO PS106. And that's included in a larger proposed ANSI standard for these foam pans and trays. But what happens, and this happens with manufacturers, these are all foam pans and trays, and with this 2-pound ball being dropped 3 feet, in most of these products, it's creating an impact zone, a dent, a crater. Now, if somehow that impact zone is not repaired or addressed, it's going to collect gray water. And gray water is what comes off of human beings when they soap, and it has the remnants of our cells and soap, and eventually microbial growth. Now, this is just good old 3-pound foam, of which there are several trays and pans out there made with 3-pound foam. And again, if you guard against these impacts, or if they happen, you repair them, you're going to be okay. But oftentimes in the hurry of production, come on, get her done. Maybe they aren't addressed, or they're not addressed correctly, and so that potential void or some of the void. Now, this is an example of that honeycomb matrix, 10 times stronger than the EPS foam beneath it. And as you can see, with that type of build, that type of construction durability, you don't get the impacting, the denting, and therefore there's no real area for gray water to collect. So please be aware that can be a critical part of your selection process as to whether you're going to use a certain product. Okay, now I think most manufacturers, most consultants, people who are trying to advise a contractor, an architect, a spec writer on a product or products will say use the system. So if you're going to use a prefab tray and pan, which more and more people are, oftentimes they come with a prefabricated foam curb. And what we're trying to minimize or reduce or eliminate is scenarios like this, where you see a curb was built, the membrane was punctured by the person who was attaching the lath and mortar. And so because of issues like this, you're seeing a variety of manufacturers make foam curbs. And I'm going to grab a couple foam curbs here. Here's a simple, it's a cross section of a foam curb. And they are usually typically thin set down to the concrete substrate. And a lot of people who haven't worked with these products will go, they can't believe this is going to be durable enough. But when you use a foam curb and thin set it down, it's very difficult to get off the substrate. Now, one thing you don't want to do, if you have glass doors, partitions, please do not use the foam curb as an anchor point for those glass doors or partitions, because they weren't designed to hold those type of attachments. There are also, for those of you who still like to use wood block curb core or concrete. This replaces the lath and mud that goes over that core. All right. And again, what we're trying to minimize is installer who wants to anchor down their 2.5 wire lath over their curb using a staple gun, of course, is going to puncture the membrane, and you're going to have a leak before you ever start. And I wanted to show you, by the way, there's nothing wrong with lathing and mudding a curb. It's been around a while and can be done very successfully by a skilled craftsman. Here you see where the lath was formed, and you can see the membrane underneath it. You don't see any mechanical attachments of the lath to the curb core, and you can see how the contractor has, through his skills, been able to form both the face and the top of the curb. Of course, you want to, if you're going to go that route, make sure you slope back into the curb so water that splashes on the curb will roll back into the shower and not outside. All right, well, let's look at some areas where, okay, I get it, Dean, slope to drain, we need to do it in shower pans, understood. But there may be areas outside of the shower where this comes into play. For example, in Europe, it's required every bathroom in their drying area has to have a drain, okay? And you're seeing it more and more in US building projects, whether they're residential, institutional, hospitality. Why? Because, well, you know, toilets overflow, bathtubs and showers overflow, so do sinks. And so, you know, and of course it costs a little more money to slope the substrate to a drain that's in the bathroom, the drying area. But you know, yeah, you can get squeegees, you can push water towards the drain, but when these failures happen, when the tub overflows, the toilet overflows, they happen pretty quickly. So anything you can do to get that water migrating towards the drain right now might be a good idea. On the slide image to the right, you see we're in a health club, a high-end health club. Now there's linear drains all along the front of these individual shower cubicles, but as a backup plan, because what you don't want, and we discussed this in other presentations, when you're in a health club or kind of a communal shower type scenario like this, you don't want to be sloshing through everyone else's gray water, okay? And so because these linear drains are sloped towards the front of the showers, you might get some gray water sloshing out into the areas of common exit and entry. So this drain in this location will help prevent that from ponding up and getting too deep. Of course, again, part of the system is if you're going to have the slope to drain in the curb, make sure you have the best drain possible as part of your project. And I think everyone's familiar with the typical clamping ring drain. I'm searching around here for my samples laying around. Been around for a long time, okay? The challenge with a clamping ring drain is they're gonna have that concave dip down into the base, okay? And whether you're using a sheet or liquid, often challenging to waterproof that detail. So a variety of manufacturers have come out with prefabbed flashings that are made at a variety of different heights to accommodate that transition from the mortar bed down to the base of the clamping ring drain. Very helpful, because the number one area of failure, folks, the number one area of failure when a forensic expert goes into a shower pan that's failed is usually the membrane attachment to the drain, okay? So these type of products really help. Now, in addition, what we've seen is, now I'm gonna reach over, bear with me while I go around the screen here. There are now clamping ring drains that have the clamping ring on the same plane. And let me see if I have another example. Right here, I'm reaching, I'm bending, but here you see the clamping ring is on the same plane, all right? So that eliminates that awkward transition down from the slope to drain. In these type of drains, the weep holes are actually in the throat of the drain. That's a second option. Of course, some of you are probably familiar with a bonded drain flange. There is no clamping ring on this at all. It simply is a bonded drain flange, which as part of this system, the PE, polyethylene membrane, is bonded to the drain flange with either a modified or non-modified thin set, depending on the manufacturer. But at that point, your sole attachment of waterproofing to your drain is the thin set on the membrane attached to the bonded drain flange. So several different options available for you in that respect. Another area where slope to drain is not considered is exterior decks, walkways, plazas. And you get into along the coastal regions of the U.S., and this has become a very, very popular upgrade to a lot of custom homes and remodels. And again, I've been on projects where unfortunately someone sloped the deck back into the house. That didn't work out too well, or there's no slope at all. And you have to have that same 1/4 inch per foot. You've got to have that water, whether you've got scuppers at the end of the deck or you employ drains. You've got to have a way for the water to get out of that system, off that system. Harkening back to our Tile Council of North America handbook, there are a variety of details and methods used to outline the best way to do slope to drain for exterior decks, but it is critical that that slope to drain happen, okay? Now, while we're talking about best practices and slope to drain and exterior decks, one of the areas that's very critical is when you waterproof that deck, make sure you flash up onto the exterior face of the house or building. I know that sometimes that's difficult because it's a remodel, there's stucco there, there's some kind of siding there, but I will tell you, in my travels over the last 21 years, I've seen a few failures where for some reason, someone decided they could just butt up the membrane to the base of the house and not flash it up. And of course, you can see here what happened over time. Water found a way out of the system. I don't think there was a slope to drain on this either, because water just collected and ponded where the deck met the house and eventually flowed down underneath. Also, too, if you're going to have sliding doors on your deck, best practice is to put that membrane down before the tracks are put in for the doors. Extend that membrane, if you can, a couple feet into the house, because even with the best practices in the world, if you get a lot of wind blowing towards your house or your building, it will drive that water right through those doors. And so knowing that if you have membrane a couple of feet extending beyond into the house or building, you're going to minimize water damage. Of course, deflection, that also ties in, as well as slope to drain and your other concerns for waterproofing. We have seen, a lot of tract construction or commodity construction go from 16-inch on center to 19.2 to out west here, 24-inch on center is kind of like coin of the realm. And so if perchance your deck employs 24-inch on center framing, you could have a concern with deflection. Worth noting that a 1/4 inch per foot is all you're allowed every 10 feet. That's for ceramic tile. A 1/4 inch per foot deflection. Natural stone is 1/8 of an inch. If you get involved in projects where you're trying to do exterior deck waterproofing, maybe you've got your slope to drain, everything else is up to snuff, but if you feel that deck's not engineered to support the weight and mass of an exterior deck, please don't rely on the tile contractor to solve the problem. This is an engineering problem that should see the attention of a qualified professional to address what needs to be done to reinforce that deck. And of course, part of any installation success or failure is, we're talking about decks still outside, is if you're going to do a deck and you're going to have slope to drain, you're going to have all the waterproofing done correctly, and it's reinforced so it doesn't deflect, make sure you put the correct soft joints in the areas and the spacing recommended. Of course, you can put those soft joints where the grout lines are to minimize, the aesthetic, horribly ragged look of cutting through the tile work. Run these soft joints where your grout joints are located. And a great source of that information is Tile Council of North America. They have a whole compendium at the back of their book, EJ 171, that does nothing but focus on different types of soft joint scenarios and how to approach them. I wanted to bring this up. It's sort of a left field scenario, but it keeps coming up. So I just want to throw one slide because in our efforts to reduce costs, remove costs, and hasten the waterproofing process, we're sometimes seeing unsuitable substrates being used in wet areas. Please be very aware of what the International Construction Code says are not suitable substrates. We're talking about drywall, green board. USG, who makes drywall and green board, says don't use it. It doesn't have a whole bunch to do with shower pans and slope to drain, but because it's part of that assembly, and we see this being done in certain locales, realize, again, this can, if the incorrect substrate's used in that part of the detail, it can lead to problems sooner than you would like them to occur on your project, okay? Now, we've talked a lot about projects and practices that maybe deviate from the best practices, the standards you want, but let me reassure you that we show you these examples just to illustrate what you don't want to do. By and large, the majority of tile contractors out there are doing very good work. I will tell you that there's a strong ongoing effort from manufacturers and various tile and stone related associations to upgrade the quality. And so work like this can be realized in your home and your project. You know, beautiful natural stone of varying sizes, you know, flowing into a linear drain. And by the way, we talked a lot about, you know, clamping ring drains and typical slope to drain assemblies with that detail, but realize, again, with linear drains, you're still going to need that same 1/4 inch per foot. And again, you see some wonderful examples here on both the left and right hand images of high quality work that's going on in today's market. Again, some more glamour shots of, you know, this is a type of work that you can enjoy for your project, for your home. And, you know, one of the ways that you do that is, of course, you ask for qualified labor. And as I mentioned a couple slides ago, a host of manufacturers and a host of associations within the tile and stone industry are really doing a lot to make sure they upgrade the quality of the average tile contractor's skill set, okay? Here you see some of the groups: TCNA, NTCA, CTEF, ACT. If you're an architect watching this, please, by all means, use master spec to call out for qualified labor. You know, if enough projects and enough architects are using this language, it's going to assist our efforts to make sure more contractors avail themselves of that level of quality and knowledge in their own day-to-day installations by going to one of these organizations and getting trained up in the manner required. You know, a lot of very relevant topics are covered in these training modules that are going to be relevant to their ongoing success and to your project's ongoing. And so one more look at some of the groups here with some of the contact information as far as websites, emails, and by all means, the future of our industry really is based on the quality of installation, and we see a lot being done to improve that. Part of those efforts are meeting here today for a while on a webinar. I appreciate all of your time. And at this point, we're going to segue out of this presentation. I'm going to say thank you very much.
Dean, great presentation and lots of good information there. And I want to second my opinion that qualified labor is very important in our industry, and it can start with the architects and the spec writers to identify that it's very important. We also ask that those architects and spec writers help us hold those specs, right? Hold that qualified labor. So that's great. We have some questions here for you, and
okay.
I'll go through them with you. The first one is, can you give your opinion about using linear drains without weep holes?
Well, you know, with weep holes existed for many years with a clamping ring drain because you had that mortar bed assembly and the membrane was located at a spot in the drain where you had a mortar bed assembly, water would migrate to the tile, and when it hit that membrane, it had to find beyond the main drain. at the top of the assembly, the weep holes allowed for that migrated moisture to flow towards the drain and not stay in the system. Well, with linear drains, a good analogy would be a bonded drain flange. A bonded drain flange doesn't have any weep holes. You've got a topical membrane per ANSI 818.10 bonded to the top of the mortar bed, or could be the prefab tray, flows right into the drain, goes down the throat. The same mentality holds true with the linear drain. You're going to, and there, in fact, speaking of linear drains, there's a little chunk of linear drain, but in some cases, the manufacturer might have the membrane bond to the drain body. Other cases, the manufacturer will use a liquid membrane to flash over the stainless steel flanges, but the water staying on top of the system and flowing into the drain body down the drain throat. So there's no real need for weep holes beneath it because water's not going to get to that part of the assembly.
Great. Another one of our attendees, you had mentioned the deflection and information, and they were just wondering if you could go over that deflection information one more time.
Sure, I kind of rushed through that. There are standards for deflection, which simply means how much can that substrate move, because obviously if it moves a significant amount, you're going to cause damage to your tile or stonework. L over 360, for those math fans out there, I just translate that to it translates to 1/4 inch every 10 feet. That's all you're allowed for ceramic tile, that much deflection. Anything more can possibly result in failure, broken tile, loss of bond. Now for stone, it's even higher. L over 720, that's 1/8 of an inch every 10 feet. That's all you're allowed. So those are pretty exacting requirements. And I think sometimes people are shocked when they hear that, but these are part of best practices. If you don't want, and damage has happened. I mean, if you get a floor that's moving a lot, deflecting a lot, tile is very, very rigid, very dense. It doesn't bend very well. So therein lies, that's why the requirements are there, to make sure that that doesn't happen.
Hey, before I forget, all of you attendees that are still here, if you are looking for a CEU for ID, CEC, or AIA, please look at the screen. Dean has his phone number and his email address there. I also did put it in the chat screen, but please contact Dean and he'll assist you in getting that CEU. Just wanted to remind everybody.
Thanks, Jim.
We do have another question, Dean. The ASTM manual that you held up that you talked about, is there a cost for that, and how do they go about getting that?
Well, of course, there's a cost to generating them, but I think most manufacturers out there, and we're one of them, if you're an architect, a contractor, if you're someone in the industry who needs an ANSI Standard manual or a TCNA manual, we'll send you one. So, I mean, you've got my email address, my phone number. You can contact, and by the way, I think we've concluded the AIA portion of this program, so I can say you can contact Noble Company or myself, and we'll be glad to get one to you, okay?
Great, that's a great offer. I hope people take advantage of that. That's fantastic. So someone said, I keep hearing hot mop is going to be outlawed. Any thoughts on that? And just maybe you need to real quickly talk a little bit about it and how it's a West Coast system that is used a lot on the West Coast, Dean.
Yeah, it's interesting you bring. I was just in Ventura a couple of days ago, and there are people in Southern California and in Sacramento. It's these pockets where hot mop. And if you think about, we've all seen them. There's that truck driving down the road with that bubbling truck of tar that's fuming and looks really messy. That's essentially what hot mop is. And what they do is they go into whether it's a residential or commercial shower. They'll have some forms to create the slope, and they'll pour out and shape the hot mop, and it'll cure and dry. But and I'm being careful. I don't want to take one stance or another. But some people have concerns about it's an oil-based scenario. There are certain fumes. When we look at environmentally friendly ways of doing things, could there be other ways besides hot mop that would work and be more environmentally friendly? Possibly, but it's stubbornly, really, it has its advocates, people who like to use it. And with any waterproofing system, there are pros and cons. And I think one of the challenges I've heard anecdotally over the years and seen a couple times is that, especially in California, things tend to move a lot, right? Hot mop over time gets brittle with age, it cures out, it gets hard. So if there is some type of minor movement, that can impact the waterproofing and over time cause a possible failure. But it's been around a long time. I keep hearing rumors that it's going the way of the dodo bird, but it keeps stubbornly hanging on.
All right, that's great. So talking about trucks and truck drivers, is that Johnny Cash's guitar behind you?
Whose guitar?
Johnny Cash.
Well, no, Johnny's left the building, but
all right. I'm just kidding. We had someone ask that question. So, so someone's putting. So, Mark Robin, please send your email request to Dean, and he'll help you out with the TCNA handbook. All right. Yep. Thank you.
Mm-hmm.
Let's see here. All right, and we got, I don't know what that means. Someone asked if you want tea.
What?
Hold on. Minimum water drain slope is recommended to be 1/4 inch per foot minimum. ADA requires 1/4 foot per maximum. This seems to be, this seems to require perfection to accompany with both standards. How can a contractor deal with the nearly indirect conflict requirement? That makes sense?
I think it may be just, it's sort of like describing the same scenario from different ends. In the one sense, ANSI Standard says it has to be at least 1/4 inch per foot, at least. But with ADA, they're saying maximum, because what can happen is people have done sloping to drain that's more than 1/4 inch per foot. But when you have someone who may be have a walker or in a wheelchair or needs some type of assistance because of some health-related reason, that additional over 1/4 inch per foot could cause an increased slip fall concern. So I think that's why ADA says no more than. They don't want to see a slip fall, and ANSI Standards say at least, because what they don't want to see less than. They want, so they're arguing the same point from different directions. What you want is 1/4 inch per foot, and there, again, if you want to, let me back up a second. Make sure the prefab pan or tray that you work with has that 1/4 inch per foot. I'm not sure all of them do have that 1/4 inch per foot, but there are ways, again, using a level, people will use street sticks, because if you think about it, it's not too difficult to math. If you have a 3-foot shower pan, 3 times 1/4 inch is going to have to rise 3/4 of an inch from the drain to the wall. And and I've seen people literally take that measurement, make that mark on the wall, put street sticks in, whatever it takes you to get that slope. But there are a variety of ways that it can be done.
Great. So I think you addressed this, but is it okay to install the sloping mud bed directly on top of a concrete slab, or should the mud bed be kept separated from the concrete?
I think most times a contractor is going to use like a 15-pound felt paper or rosin paper, and they'll put that down, and then they'll put their dry pack mortar bed. They will call it sometimes. They'll call it a slip sheet. It's not a crack isolation membrane. It's just a interface between the concrete substrate and the dry pack mortar bed. They'll use 15-pound felt paper to build their shower pan on top of.
All right. Is there a standard for testing the foam shower pans, and are they ANSI? Do they meet ANSI requirements?
That is a great question. And again, if you get that sleep-inducing article I've wrote, I do make a point in there that's one of the challenges. It's kind of like the wild, wild west out there. There's at least 5 or 6 foam manufacturers. They're being used. They started residentially, but we're starting to see more of them commercially now. And they're working on an ANSI standard. The challenge is, you've got to get all the manufacturers to agree on a baseline of what's going to be acceptable. So as of unless something's changed radically in the last couple weeks or months, I believe there's no ANSI standard so far. The one thing you might want to look at is the PS 106 ball drop test, and that is the sprayer pan I'm using, is it strong enough to resist that ball impacting the foam pan or tray?
I'm typing in your email and phone number to someone here. Sorry about that.
Not a problem.
All right. So next question. What's the best way to coordinate the correct flanged, in parentheses, drain with the correct membrane assembly?
Okay, I think when you say flange, obviously there's a bonded drain flange. Certain manufacturers have certain ways of approaching that. And I think to try to give an accurate answer, it's not too long-winded, depending on what type of drain you have, okay? If you have a clamping ring drain, you've got your option of a loose laid shower pan or a bonded membrane shower pan. Now, if you happen to have a manufacturer that makes that bonded drain, that NobleFlex flashing, it'll make your life easier at that transition. If you're a linear drain, you've got basically two options. You're going to have a stainless steel flange, which in that case, you'll probably have to use a liquid membrane to flash over the stainless steel flange to create that watertight transition. There are manufacturers that actually anchor a sheet membrane to the drain body of the linear drain, but you want to look at what type of drain you're using, and if you have a choice, then you might want to make that choice of drain based on what type of waterproofing system do you want to be part of that drain assembly.
Dean, let me say this real quick. So we've talked a lot about methods and standards from ANSI and the TCA handbook, but it's real important that everyone understands many manufacturers have their recommendations, and their recommendations supersede ANSI or TCA. You always want to follow the manufacturer's recommendation for their products. Very important, all right? They're the ones that are going to warranty that product. So follow their recommendations.
Yeah, all
right. Let's see here. It looks like we got one more. All right.
Okay.
With larger commercial bathrooms, can we get away with 1/8 inch per foot drainage? 1/4 inch per foot may result in substantial high differences across the room. In wet areas like showers, 1/4 inch for sure, but for non-wet areas like large bathrooms, the drains are more for emergency situations. Please advise.
And he brings up a good point because, traditional wet areas, i.e. shower pans, industrial or gym locker room showers, you want to stick to that 1/4 inch per foot. But we do see, like, I'll call them common core bathrooms, where you may have in a commercial building, these big bathrooms, and there are drains being placed in there. It's not your typical wet area. But I would say anytime if you can get, I've been told by some consultants, they say, Dean, if I can get a marble or ball bearing to roll to the drain, I'm happy. Okay, so there's not a requirement in those areas because they're not typical wet areas. But if you have drains in a bathroom area where you're washing your hands, where you grab your paper towels, wherever, by the urinals, if you can get a slope, get a slope. It'll make your maintenance people's life easier, because when something does overflow, having that slope to drain will get that water moving towards the drains that much more quickly. I don't think anyone's going to, if it's not 1/4 inch per foot, because it's not in a typical wet area, it's not going to receive the same scrutiny as it would if you were in a shower pan.
All right, great answer. So I want to thank Dean. I want to thank all 210 attendees to this webinar for being here. And for those 150 that are still here, I want you to know, please register for our next webinar. It's June 11th, and it's titled Cleaning, Sealing, and Troubleshooting Solutions for Porcelain Tile and Stone Surfaces. So look for your invite to come soon. Dean, fantastic program. Thank you again. You do a great job as always. And give me a call soon, okay?
All right, you take care, folks. Everyone be safe out there, okay?
Be safe. Bye-bye.